This is Rishit from AML Department of Global Academic Technology here to explain the project of predicting delayed dialysis in ICU patients with acute kidney injury. This presentation explores the challenge of predicting delayed dialysis in ICU patients with AKI. The most important part of this model is to discuss the accurate prediction models and explore key features predicting delayed dialysis.
Let me now first show the slides of the project so that we will have a clear outline view of the project. Further, we will also go into the codes and also show the analysis of the models used. The problem statement of this project is patients with acute kidney injury face severe complications if dialysis is delayed. Currently, determining the optimal time for initiating dialysis is largely based on clinical judgment, which can lead to inconsistent treatment outcomes. So, this project aims to address this challenge of predicting whether a patient will require early dialysis or not in faster and an efficient way. The main objective of this model is to develop a ML model, that is, machine learning model, that can predict the need for early dialysis based on key clinical features. Now let's discuss about the project overview. As I said earlier, the project aims to predict acute kidney injury, that is AKI, patients in the ICU who receive delayed renal replacement therapy using various ML models, that is machine learning models. Now coming to the data sources. As we all know, data source plays a very crucial role in accuracy of an ML model. So we have derived the dataset from MIMIC4 database, focusing on ICU patients with acute kidney injury. Data extraction also involves multiple SQL queries to gather relevant clinical features. Feature engineering: new features are created based on interaction between existing features. Normalization: standardization of features is done in this step. Dimensionality reduction: it is used to reduce the number of features while retaining important information. The technique used in this model is PC, that is Principal Component Analysis. Now coming to the EDA, which is Exploratory Data Analysis, where visualizations are created to understand the distributions of numerical variables and identify potential outliers. Basic steps of this project are: first, importing libraries. Essential libraries such as pandas, numpy, scikit-learn, and XGBoost are important for data manipulation and modeling. Then, the clean dataset is loaded into data frame for analysis. Key features are selected based on their importance and correlation with the target variable. The dataset is split into training and testing sets to evaluate model performance. The last but not the least step is model training, where various models are trained on the training set and their performance is evaluated using metrics like accuracy, precision, recall, and F1 score. This is the most important step as we can compare the accuracy between various models and then deploy the models for our project. In this slide, we are gonna discuss about the models used in our project by showing the parameters and the accuracy of each and every models used. First is logistic regression. The parameters used are anion gap minimum, creatinine minimum, etc. and the accuracy approximately 75%. Next is random forest classifier. The parameters used are anion gap mean, creatinine mean, etc. and the accuracy obtained in this model is approximately 80%. Next is exhibit classifier. Same, the parameters are used, but the approximation of the accuracy is around 82%. Next is fine-tuning. Hyperparameters such as n-estimators match rate were also included to check the accuracy, and at last it obtained approximately around 82%. At last, we used bagging and ensemble methods, where the parameters were similar to random forest, but
The accuracy was achieved around 78%. So therefore, by analyzing these various models, we conclude that the XGBoost classifier is the most efficient model to be used in this AKI model, so that it shows the accurate decisions whether the patient should go under early dialysis or not. For our project deployment, we used IBM Linux One Community Cloud, a highly secure, enterprise-grade environment optimized for AI/ML workloads. The deployment was carried out on an Ubuntu 22.04 LTS virtual machine via the LNCC instance. Here's how we use this environment. We containerized our model using Docker and deployed it in the Linux One instance, enabling scalable, isolated execution of prediction tasks. For interacting development, debugging, and final testing, we use the pre-installed JupyterLab environment. Leveraged libraries like scikit-learn, XGBoost, SHARP, Lime, and Pandas, all pre-installed on the Linux One instance. Using SSH with an imported open SSH key, we authenticated into our instance securely and ensured all actions were in compliance with IBM's cloud policies. This deployment allowed us to test the model performance under real-world conditions, simulate API calls and user input handling, ensure quick interference time even on large patient datasets. We utilized the infrastructure depicted in this architecture diagram. Through the Linux One Community Cloud dashboard and Jupyter Notebooks, we interacted with the remote instances from the browser. The container came pre-installed with essential frameworks including Python, Jupyter, PyTorch, TensorFlow, etc. The base OS was Red Hat and Ubuntu, which enabled us to isolate a model environment using containers, improving reproducibility and version control. Supported integration with various data sources such as local CSV files, MongoDB, IBM DB2. This robust environment provided the ideal foundation for secure, scalable deployment and testing. Once the environment was ready, we proceeded to deploy our model. This included our serialized model was uploaded directly to the instance using SCP and executed using Python. We ran prediction tasks, visualized outputs using matplotlib and SHARP, and verified feature importance in a browser-based JupyterLab environment. Input CSV files were passed from local storage, processed using our retained pipeline, and prediction results were returned instantly. Start from the first model, that is, bagging frontier. As you can see here, we have imported various packages from various models. That is, we have imported Voting classifier from sklearn.ensemble, XGBoost classifier from XGBoost, random forest classifier from sklearn.ensemble, and classification report from sklearn.metrics. We load the dataset and then split the dataset into training and test set so that our main aim is to train the model perfectly. Then we define the reduced parameter grids for XGBoost and random forest. Then we also combine all the parameter grids and then initialize the models, creating the voting classifier, and then we also use a smaller subset of the data for initial tuning. To get the best model using random search dot best estimate. Some sentences are printed by giving some function values.
so that it makes the user friendly and anyone can access our model and understand the reports. Here we have also created the predict RRT delay as a function in which it contains some of the parameters. These parameters are used to define whether the model displays the patient has the RRT delay or is it early. And these values for the parameters are given in a numerical form. It is not that the value should be the contact as I have given. It can be any values based on the health reports of a patient. These reports can be obtained by giving just a blood sample to the any nearby hospital or any clinics, and after by printing the result, we get the output whether the RRT delay is predicted or not. Finally, we get the accuracy as 81.4% by using the bagging fine-tune model. Now let's see the bagging model. Here, this bagging model is a bit different from the bagging fine-tune model. Here the packages are also imported as same as backing fine-tune model. The steps flow goes on the same as the previous model. Same loading the dataset, split the data into training and test set, initialize the models, combining the execution and forest using routing. But here we have also evaluated the model using some parameters of the accuracy, that is precision, recall, F1 score, and support. And the final report we have obtained as the accuracy as 0.80%, that is 0.80, that is 80% of the model, 80% of the accuracy of the model, which is a bit lower than the bagging fine-tune model. So therefore, we can clearly say that the bagging fine-tune is more accurate than the bagging model. Use the predict RRT delay model with the same parameter as the previous model. Here we have also used calcium max, creatinine, which also we have seen in the previous model. These model values are given in result as the function, and then we can check the result. And the output of this model is also shows that the RRT delay is not predicted. Now I am showing you the cleaned data set which has removed all the missing values which was present in the previous data set. As you can see, there are many missing values and it is uneven. And so using this has the low accuracy of any model. So therefore, by using this clean data model, this increases the accuracy of the see about the logistic regression model, which is completely different when compared the previous two models. Here the packages are imported are different compared to the previous models like train test split from SQL-init model selection, logic regression from SQL-init linear model, classification report from SQL-init metrics. Here we have also loaded the dataset and assigned the variable as df. In here, we select the top 5 features and the target column, and then drop the rows with missing value. This is also a part of a data cleaning, which also increases the training accuracy of the model. And then we also split the data into training and testing sets, and then apply smart package to balance the data set. Here we also check for the best hyperparameters and model. Evaluating the model with this test would be great. So function to predict early dialysis is also used with the same parameters as the previous models. So therefore, we have used here a if-else function, that is, if prediction of zeros, the early dialysis is recommended, else it is not recommended. So now by giving the values, if the prediction value will be zero, then early dialysis is not required. But if the value of the prediction is 1, then it is early dialysis is recommended. Checking to the random forest model, which is also a best ML model in training these datasets. Here also we have imported the train test plate from SQLNet model, random forest classifier from SQLNet and Sunbird, classification remote from SQLNet metrics. The dataset is loaded and select and the top 5 features and the target column are selected, same as the previous model, it is logistic regression. The rows are dropped with missing values and then the data is split into input features and target features. Splitting data into training and testing sets, and then the smart package is applied to balance the data set. Therefore, there are some set of different parameters as compared to n estimators max depth are also used in this model.
Here we train the model by using the X resample and Y resample. We can also get the best model by using the random search.best estimator and then print the classification report and then use the predict early dialysis function with the same parameters that we need to predict the early dialysis or not. Here, if the prediction value is 0, then early dialysis is not recommended. Else, if it is prediction is 1, then early dialysis is recommended for the patient.
Discuss on XGBoost model. Here earlier we had discussed that XGBoost model will be the most accurate model, that is with 85%. Here the train tested package is imported using the SKLNet model classification report from SKLNet matrix model. The dataset is loaded and the features are updated as per the requirement. Then the rows are dropped with missing values and then the data is split into features of X and Y. The splitting data is separated into training and testing sets. Then we also apply the smart package to balance the data sets. Then the XGBoost classifier is defined with some of the parameters like n estimators, max depth, learning rate. We also search for best hyperparameters and model by using grid.bestestimator. The model can be evaluated with the test set, that is, bestmodel.predict of x of test. That is, predicting early diagnosis for ICU patients with acute kidney injury. Five classification models were evaluated using the ROC-AUC curve: logistic regression, decision tree, random forest, extra trees, and support vector classifier. The ROC-AUC curve measures a model's ability to distinguish between classes, where a higher AUC indicates better performance. Among the model, the SVC achieved the highest AUC of 0.73, followed closely by logistic regression at 0.72. These results highlight their strong classification ability despite their simplicity. Tree-based models performed slightly lower: decision tree 0.69, random forest 0.68, and extra trees 0.66, possibly due to overfitting or data imbalance. All models outperformed random guessing, but SVC and logistic regression stood out for their consistent and reliable predictions. These models could serve as strong candidates for deployment or further optimization through ensemble methods or advanced. At the last part of this video, I would like to show the user interface built for this model using the Unreal software. Unreal is a software which helps us to build a web app, which is a basic app that can be used by any user easily. Here I have just installed the Unreal Appling software and then I have imported it and connected using the API key provided by the Unreal server. And then by adding the callable part of the Unreal server to my code, it creates the complete code into the web app. Basic user interface that has been created by the Unreal software. Here it has mentioned all the parameters which I had needed to check the status of the dialysis, and by giving the numerical values out to all the parameters and then clicking on check, the result pertaining to above values is displayed accordingly. I would like to end my explanation of my project. Thank you.